In this video, we'll explore the limitations of reactions involving aniline and other arylamines. We'll also explore the challenges in working with phenols and anissols. Aniline and arylamines are so activating that they will react in a halogenation reaction in the absence of a catalyst and will form multiple products. It is essentially impossible to form a monosubstituted product. Further, note that this reaction must be done without a Lewis acid. And this is for the same reason that Friedel-Crafts reactions should not be done with arylamines. We'll explore this issue a little bit further in the video. As it turns out, phenols and anisols are also highly activated. Halogenation reactions can be done without a Lewis acid catalyst, and multiple products might be formed. So as it turns out, phenols and anisols are not quite as activated as the arylamines. Multiple products may also be formed for sulfonation, nitration, and Friedel-Crafts reactions. I don't include this diagram in your chem activity, but I include it here just so that you have the visual. Phenol will react with bromine without a Lewis acid and likely will form multiple products. Aniline and other arylamines suffer from further problems, however. So for instance, in the case of nitration reactions or sulfonation reactions, we have this sort of issue. And I combine these two reactions because both of them involve working with strong acids. And if you expose aniline to a strong acid, the amino group will act as a base and essentially will get protonated. So as you know, the amino group is ortho-para-directing. However, once the amino group is protonated, now we have a meta-director. So for instance, if we look at this particular reaction, in the presence of the protonated amino group, instead of putting the nitro group into the para position, or possibly the ortho position, the main product will be in the meta position. Sometimes, however, there are other issues that result in working with this protonated, deactivated benzene. And essentially, what forms are a series of oxidation products, dark colored tars, which are very difficult to work with. So in other words, anytime that you're working with an arylamine or when you're working with aniline, you should avoid reactions that involve using strong acids, such as the nitration and the sulfonation reactions. In a similar way, we must avoid reactions that involve the Friedel-Crafts catalyst, in other words, the Lewis acids. So in the same way that strong acids react with the amino group, the Lewis acids react with the amino group. So Friedel-Crafts reactions cannot be done with aniline. So essentially we'll form this complex, and this complex, if anything, would, instead of being ortho-para-directing, would be meta-directing. So essentially we just avoid using Friedel-Crafts reactions with aniline and other arylamines. Now, there's an important distinction between aniline and the arylamines and phenol and anisols. Although phenol and anisols are highly activated, the oxygen in the phenols and the anisols is not as good a base as the nitrogen that's in aniline and the arylamines. Therefore, that oxygen does not get protonated in the presence of strong acids or the Lewis acids, or at least it doesn't get protonated as much. And therefore, we don't need to worry about resulting in a protonated oxygen and essentially creating a meta-director. In summary, although the phenols and anisols are highly activated, they can be used in nitration and sulfonation and Friedel-Crafts reactions. Fortunately, there's a way around the fact that the arylamines result in multiple products and cannot react with acids. Same case with phenols, that they result in multiple products. And that is, we can react the amino group and the alcohol group with an acyl halide in the presence of pyridine. In this case, the pyridine acts as a solvent, it is non-reactive, and the acyl halide will acylate each of the respective groups. As a result, the corresponding groups are only moderately activating and therefore will not result in multiple products. And in the case of the amino group being acylated to form the amido group is not as basic, and therefore it will not be protonated by nitric acid or sulfuric acid, nor will it interact with the Lewis acids. We put this group on temporarily, we then do any corresponding reaction that we want, and then we remove the group. So to summarize, by acylating, we prevent the aryl halides from having multiple products. We also prevent any sort of modification by acids. In the case of phenols, we prevent the phenol from having multiple products. Once we finish doing any corresponding reaction, we then remove the acyl group by reacting with sodium hydroxide in water, in other words, basic conditions. And so we reform our corresponding aniline and phenol. Here's an example of a synthesis involving aniline to produce para-nitroaniline. This, of course, is very similar to what you did in the lab. You started with the acetoanilide, but if you started with aniline, the first step would simply be to acylate the amino group. We form the amido group or the amide functional group, and then we can do the nitration reaction, and then after we remove the amido or the acyl group and once again have the para-nitroaniline. I'd like you to consider this particular exercise and see if you can come up with a synthesis for converting aniline to para-amidoacetophenone. So of course this particular reaction involves a Friedel-Crafts reaction, Friedel-Crafts catalyst. Therefore we will first of all need to protect the aniline group by acylating it. So the reaction would look something like this. The first step involves the acylation. Note that this is done in the solvent of pyridine, and in the absence of the Lewis acid, we'll simply acylate the amino group. Then the next step will look like you almost use the exact same reagents, except this time we'll include the Lewis acid. This will result in the acylation in the para position. And then finally, we'll use basic conditions to remove the acyl group. I hope that this video has helped you understand the limitations in working with aniline and arylamines, as well as working with phenol and anisols. Fortunately, there's a workaround by simply acylating these various functional groups, thereby preventing multiple substitutions, as well as allowing the amino group, transformed to the amido group, to react with various acid type of reactions.